It's great to have the opportunity to present at this conference. In this presentation, I will talk about our engineering and physical sciences UK government funded research that has been developing a chemical means of recovering precious metals from electronic waste, and how we have been working with artisans in India to create new jewellery from this material. In particular, I will talk about how traditional craft techniques connect with this chemical process of precious metal recovery. Technology in this conjunction, as Heidegger suggested, may be considered as more of an art and a relationship, and ultimately an ethical way of relating to society. I will start by providing some context for our work in precious metals. I will then move on to outline three traditional techniques that connect with a hydrometallurgy process, the name given to the chemical process of metal recovery. And finally, I will conclude by discussing the value of thinking about technology as an art and as an ethical way of relating to society. So, to provide some context to this research, it's estimated that we have mined around 171,000 tonnes of gold, half of that in just the last 50 years, with just 52,000 tonnes remaining underground. The gold above ground could fill Centre Court at Wimbledon in London with sides of around 20 metres high. When you add to this the fact that the European Chemical Society, as part of their endangered elements periodic table, have now declared that if we continue to mine at the current rates, our copper and silver will run out in less than 100 years. Gold, too, has a rising threat from increased use, so urban mining is increasingly important. We need to acknowledge that we are now living in the waste age. We have had the Bronze Age, the Stone Age, the Iron Age, and in the future, historians are likely to look back on this period of time and acknowledge that we are now living in the waste age. So urban mining, that is recovering precious metals from electronic waste, is increasingly important. You need approximately 41 mobile phones for 1 gram of gold. Interestingly, too, the yield associated with urban mining is far greater. From 1 tonne of ore mined from the earth, you can expect to generate around 6 grams of gold. But from 1 tonne of electronic waste, you can generate around 300 grams of gold. This could be described as molecular gold panning. In Europe, we are only recovering around 15% of precious metals from electronic waste, the rest often ending up in landfill. Hydrometallurgy is a chemical process that involves the use of aqueous solutions for the recovery of a variety of metals from electronic waste. I have been working with chemistry colleagues at Edinburgh University who started using acid solutions and then moved on to alcohols, which are much more environmentally friendly. Here I was recovering some gold and a quantity of copper from computer circuit board fingers. Hydrometallurgy can be conducted on a small scale in comparison to the dominant method of pyrometallurgy, which is conducted on an industrial scale and where everything is incinerated, generating quite a lot of CO2 and damaging the environment. During the hydrometallurgy process, Once all the metals have been stripped from the electronic components, they are mixed with other chemical compounds that selectively target different metals. So this process has opened up opportunities for us working not just with metal in its solid form, but also other states such as liquid, gas, and powder. The link here is to a short BBC video that documents my experience of working within the chemistry lab in Edinburgh using their hydrometallurgy process. One of my favourite quotes is from the British anthropologist Tim Ingold, who says, "The maker, like an alchemist, is more interested in what materials can do rather than what they are." So in this project, we've been looking for ways that hydrometallurgy and its outputs can connect with traditional craft techniques. One such output is gold powder, seen here, which doesn't look like much at all, but there is actually 2.4 grams of pure gold here. In India, where we have been working with traditional jewellery artisans, we have become aware of a technique called meenakari, which is a type of enameling. This is Mohan Prasad Verma firing the meenakari by hand. The pink meenakari seen here on the right is created from gold powder mixed with crushed pomegranate seeds. This is a very frugal way of working with gold, as it uses the material quite sparingly, but to beautiful effect. We have found that traditional metalworking techniques that also operate on a small scale and at a local level connect well with the technology of hydrometallurgy. Given the very limited supplies of gold that we have left in the world, it also makes good sense to start to explore more frugal ways of working. Damascening is an ancient craft technique that is known in India as koftgari and works with thin metal foils, 0.02 millimeters, that can cover a wide surface area. Here is Mr. Ganesh, a Varanasi koftgari expert, demonstrating the technique. In my own practice, I have been developing a type of damascening known as Nanime Zogan in Japan, which translates as cloth weave. Techniques such as damascening originally came to India and Japan from Persia via the Silk Road. And today, instead of trade networks, it is the drive for sustainability networks that is pushing innovation in techniques. If you're interested in learning more about this process, you can follow this YouTube link to see me using the technique during a residency at Greywood Arts in Ireland in 2022. You can also see more about how to make the metal foils used in damascening on the Craft EU Materials Library Hub by following this link. Heidegger, in his essay, The Question Concerning Technology, distinguished between what he described as technology that perceives nature and therefore natural materials as a resource to be exploited, and alternatively, the opportunity to rethink technology as an art and as a relationship. So, connecting the science of hydrometallurgy with traditional craft techniques and local communities has enabled us to identify values that are important to us, specifically working on a small scale, at a local level, and in harmony with nature. This is a women's empowerment project in Varanasi that we have been working with. Jewellery made from precious metals, recovered from electronic waste, especially where it has provenance, reduces their reliance on mined metals and enables artisans to meet the increasing demand for sustainable materials. Technology in this conjunction may be considered closer to Heidegger's second way of thinking about technology. That is, thinking about technology as more of an art and a relationship, and ultimately an ethical way of relating to society. Thank you very much for listening.